G'day ladies and gents, Cubic Meter here. The blast chamber multi-farm is growing. On top of the concrete converter, cobble generator and tree farm, in my most recent video we also went ahead and added on this copper oxidizer. All of you had some really nice ideas for new additions to the multi-farm. For example, I took a nether tree farm design by DrakePHOSE and added in the ability to go ahead and change the tree type that you actually want to harvest. So if I want to switch this to crimson, all I need to do is grab the crimson nylium, remove the warp nylium, then hit this note block. It will then change the recovery block to crimson, and also switch over to supplying us with crimson fungus. Then I can turn on the farm, hit this button, and simply start placing down the fungus. So this turned out to be a very simple addition to the multi-farm. However, in this video, we're going to be tackling one of the hardest block conversion mechanics in Minecraft. I am of course talking about generating dirt, converting it to mud, and then converting that to clay, and being able to harvest all three of these blocks, all from the same blast chamber. Now this will be a very interesting challenge. So to start with, we need to figure out how we're going to create dirt. Back in 1.16, a funny trick that you could do was craft dirt and gravel into coarse dirt, hoe the coarse dirt to get dirt again, and then repeat the crafting step with gravel that you generate through piglin bartering. However, the crafting step was quite tedious. Ever since 1.17 of course, we have the new mechanic of growing an azalea tree on top of moss to create rooted dirt. But you can also grow tall spruce trees above moss blocks to convert that moss into podzol. So that means we essentially have two options for a high efficiency dirt farm. We can either go the rooted dirt from azalea, or with podzol from tall spruce trees. And both of these blocks have their advantages and disadvantages. Using a dispenser with a water bottle, you can automatically turn rooted dirt into mud. Trying this on podzol however, and it doesn't actually work. However, if you were to feed the rooted dirt directly into the blast chamber, you'll find that the rooted dirt will drop as rooted dirt, but the podzol will be converted to dirt. And the only way to convert rooted dirt to normal dirt is using a hoe. Podzol can also be converted to dirt by using a shovel on it to turn it into a path block, and then destroying the path block to make dirt. However, there is a subtle issue with these processes, as they both require input from the player in order to function. And here lies the problem. If we go the podzol route, then we're going to need the player to place down saplings to grow the trees. Alright, so why not just go the rooted dirt route? After all, we can actually generate azalea trees automatically without the input from the player. However, the problem is that once we obtain our rooted dirt block, we also need to remove the log block above it in order to grow a new sapling. This automatically cuts the rate of dirt that we can produce in half, because whatever block stream input we use for the blast chamber will not only need to handle the dirt, but also the excess logs from the azalea trees. On the other hand, using spruce trees, we generate way more podzol compared to the amount of logs that we need to remove. So we now have a choice that we need to make. Do we go with the rooted dirt approach, or do we go with the podzol approach? Here's what I'm thinking. We can generate podzol automatically using the spruce tree farm, and then we can convert it to dirt using the blast chamber. A blast chamber will then give us our shulker boxes of dirt, which we can then convert to mud, which we then have the option to send directly to our blast chamber, or we can instead convert it to clay and send the clay directly to our blast chamber. So unfortunately, rooted dirt misses out for now, simply because of this extra log block, but also because there's no way to convert this rooted dirt into dirt, which is perhaps the most useful block that we want, without using the player. And while yes, I guess you could have an alt account perform the conversions for you, but the moment that you introduce another player as a requirement for using your farm, the whole concept becomes vastly less accessible to the wider community. Not everybody has access to carpet bots, and not everybody has an alt account. And even if you do have an alt account, would you be willing to run 2 instances of Minecraft to run a single farm? And while the automatic aspects of the Azalea approach would free up the player to do the conversion on the rooted dirt, this kind of way of generating the Azalea saplings is extremely inefficient and slow, on top of the fact that we already need to cut our rates in half by removing these log blocks. So taking into account all of these nuances between the rooted dirt and the podzol, I find that the podzol provides the dominating solution in terms of an efficient single player dirt, mud and clay farm. So I guess now we need to get ourselves a tall spruce tree farm that can harvest the podzol. Now to start with, tree farms have a lot of weird rules. So what I have right here is a simple setup to demonstrate what we can and can't do with tall spruce trees. If I go ahead and just bone meal these saplings, you can see we can grow a lot of trees very quickly. This is of course because I have some command blocks set up to automatically replace the logs with saplings. Now command blocks are going to be your best friend when designing any farm. For example, I also have these 2 command blocks to replace the leaves with air, and also replace the podzol with more moss. Now we need to choose the geometry and positioning of our moss to convert it to podzol and then extract it to get our dirt. Placing the moss below where the trees grow makes things a lot more convenient, and I'll show why. So if I just go ahead and bone meal these, we easily grow additional spruce trees. However, if we place our moss blocks on the same level as our saplings, I can bone meal this as much as I want, however the spruce trees will never grow. This is because out of these 4 saplings that we need to place down in order to grow the tall spruce trees, if we look specifically at the northwesternmost sapling, it creates this exclusion zone depicted by the red stained glass, where anything that is not a log or a leaf will prevent the tree from growing. And because it's always the northwestern sapling that does this, that means that any tall spruce tree farm is going to be directional. Because if we want dispensers in order to bone meal the saplings, we can't place them on these sides at all. The only places that we can put these dispensers is either on this side or this side. And if we consider the fact that we need to get the logs out of there in order to grow more trees, we'll also need to have one side reserved for the pistons to come in and push out the logs. And this is something that I kind of hate about tree farms. There are a lot of very specific rules which are highly restrictive in how you can actually process the trees. Alright, so why don't we place the moss at this level, or this level? Well, that reasoning is quite simple. Any blocks which generate above the moss will actually block the podzol from generating. And this includes the leaves that can sometimes generate underneath the saplings if I bone meal these saplings enough. And leaving some extra space for adding the mechanism which pushes out the podzol would be quite handy. Alright, another thing we need to decide is how much podzol do we want to harvest? Because the area where podzol generates is actually very large. However, harvesting this entire area is rather impractical. Because keep in mind, the only way that we can harvest this podzol is by moving in stone and then converting that stone to moss. But if there's too many blocks in the way, we're going to be at push limit and our pistons aren't going to be able to replace the podzol. And then we also need to contend with the fact that it's not 100% reliable that we can convert this entire area to moss. What I think would be the best compromise is a layout which looks like this. So what we have is 1, 2, 3, 4, 5, 6, 7, 8 length of stone, which is 3 wide on either side of where the tree grows. The advantage we get from this arrangement is that these moss blocks that we use to spread to this stone gets multiple attempts across the entire area of the stone. So we can convert this part to moss, then we can also do this part, this part, and this part, and we can almost always guarantee that we fill the entire area with moss. This means that we can maximize our dirt yields, because stone, which fails to convert to moss, will also naturally fail to convert to podzol when we grow the tree. This layout also gives us a direct path for pistons to push through and extract our podzol. So putting everything together, and what we're building towards is a pretty complicated sequence of events that we need to execute in order to get our dirt. So first of all, we need to grow a tall spruce tree to convert our moss into podzol. Then we need to crush all of these leaves and get them out of the way and extract the saplings from them. The next step is then to replace all of this podzol and any remaining moss with stone, and then once all the stone is in place, we generate the moss. And to allow our podzol to generate again, we need to remove all this crap which generates above the moss. I think it's needless to say that we're going to have a pretty complicated farm here. So here is a basic layout to start off with. What we need to take careful note about is that we need things like stone being generated and pushed in from underneath here. We're going to need bone meal supply to all of these dispensers. We're going to need leaf crushing over this entire area to prevent leaves from preventing podzol from generating. We're going to need a system out here to merge all of our podzol as well as these spruce logs that we need to remove in order to place down saplings. And all of this needs to come out of a single block stream that we can feed into our TNT efficient blast chamber. Here's where the choice of limiting these to 3 blocks wide really comes in handy, because in order to merge all this podzol together, all we need is simply 3 pistons arranged like this. When we push in the podzol, we can start a sequence that looks like this. So what we have is these 3 observers watching when these blocks start moving. Initially, we fire this piston first, which immediately pushes the first podzol in the middle down. And what is important for making sure that we can merge all this podzol together later on is that we want to use a timing scheme that makes sense and lines up really well with our final block stream. For example, our blast chamber takes a 4 game tick block stream as an input, which means there is a 4 game tick interval between each block moving in the block stream. If we also consider that we're going to have another one of these streams on the other side, that means we want this block stream to be half the speed at 8 game ticks. So, counting our observers, which each give a 2 game tick delay, from the moment that this piston pushes the first block down, we have this observer activates this rail at the same time that that piston starts moving the first podzol, which means we want to start counting from this observer. So we go 1, 2, 3, 4, 5, 6. After 6 game ticks, this piston pushes a podzol over into the middle. Then notice how we also have these 2 observers, which then go and power the center piston. So backtracking from this piston at 6 game ticks, we take away the 2 of this observer, back to this rail. So now we're at 4 game ticks. We go 5, 6, 7, 8. So this block will start moving 8 game ticks after the first block. And notice how these 2 pistons are connected together by this same rail line. This means that both of these pistons will try to fire at the same time. However, in this tug of war, it's the piston that pushes first which prevails. Something to keep in mind about rails is that they actually trigger devices like observers in the reverse order to how you power them. So even though the power comes in this side of the rail, it is actually this piston, which is powered from the end of the rail, which triggers first. So watching the full sequence, you can see the left piston goes first, then the right piston goes. And this is because we give another 8 game ticks delay, which is what this repeater is set to, before we trigger the rail line again, and what we obtain is a full, quick and simple... Oh. Okay, that makes sense. We ran this so many times that this piston has run into push limit. As I was saying, we get a quick and simple block merging sequence. And the beauty of having all three observers here is that, say for example there was a moss block which generated in the middle somewhere here. However, those other two observers will still see the other two blocks moving and activate the sequence. So that means we will obtain block stream merging no matter what chaos ensues within the growth chamber. Alright, now we have both sides set up. I've got a command block to test out the block merging. And down here, I have a simple smart piston which redirects the blocks into the 4 game tick block stream. Let's go ahead and take this for a spin. Ah, that doesn't look good. So here we have some pods or blocks lingering in the block streams, and there's a very good reason for this. Both of these block streams are 8 game ticks, however, they're trying to merge together into a 4 game tick block stream. And of course, in this situation, we have the tug of war going on, and our blocks are colliding trying to merge together. There is a simple solution for this, however. We expect a block in this block stream to move every 8 game ticks, and a block in this block stream to move every 8 game ticks, and a block in this block stream to move every 4 game ticks. That means that all we need to do is offset these two by 4 game ticks. And that can be done all the way back here. If I just break out these two rails and put 1, 2, 3, 4 game ticks of delay between these two sides, we obtain great success. If we take 1, 2, 3, 4, 5, 6 blocks multiplied by our 4 game tick block stream, we can power these pistons every 24 game ticks. And what we obtain is a continuous 4 game tick output stream. This would give us our maximum possible speed of 18,000 dirt per hour. However, unfortunately, this maximum possible speed is going to be slowed down by the fact that at some point we're going to have to wait for trees to grow, but also for water to clear out all the junk that generates on top of our moss. So what rates should we be aiming for? Well, honestly, I will be satisfied if we can at least obtain 9,000 dirt per hour, which is equivalent to the speed at which hoppers transfer items from one inventory to another. Now you might argue that it might be possible to obtain the full 18,000 dirt per hour by using buffers to cache excess podzol during times when the farm is running quickly, and then deplete the buffers when the farm is taking longer to do stuff. However, you're always going to have to deal with that edge case where trees grow instantly and everything happens way faster than usual. And then eventually at some point the buffer could just randomly overflow. So the compromise here is that by limiting the speed that we process blocks to the speed in which we can send them into a 4 game tick block stream, we can essentially withstand even the most unlikely circumstances. But the cost is that we don't always get the maximum speed possible. And I don't really mind. We're going to get incredible bone meal efficiency to actually getting podzol due to how reliably we can generate moss and podzol using this layout. This farm is going to optimize for efficiency over sheer speed, which makes sense after all. We're using a TNT efficient blast chamber, which is the whole reason why we're restricted to a block stream output. Alright, here is a really simple stone generator that I've set up to run at 24 game ticks. So this should push in some stone into these command blocks that will delete the stone every 24 ticks, which is exactly in sync with this whole system up here. Alright, let's give it a spin. Oh wait, that's not good. What's going on here? So needless to say, our stone generator generating cobblestone is not very good, because cobblestone cannot be converted to moss. Here's a really obscure fact about fluids. In the overworld, lava will schedule itself to flow every 30 game ticks. However, water will schedule itself to flow every 5 ticks. You would expect water being much faster would actually reach the center before the lava has the chance to start flowing. With these blocks in the center moving every 24 ticks split between the 2 stone generators, each stone generator moves every 48 game ticks. The solution to this is that we make a stone generator which pulls the stone away, allowing the water to flow into the space immediately. So running at an interval of 24, we don't ever generate any cobblestone. With the stone generators sorted, we now need to move on to the leaf crushers. Now we know from testing that leaves can generate essentially anywhere, and any block between the moss and the blocks where the saplings sit on will prevent the podzol from forming. And this is unfortunate because it's really easy to make a simple double extender to crush the leaves, but unfortunately these leaf crushers are going to block podzol from generating. To prevent that, we're going to need that extra block of travel in our leaf crushers. Fortunately, there does turn out to be a solution in slimestone. Now, I do not engage very often with slimestone, mainly because I'm quite terrible at it. But this seems like a pretty good attempt to me. If I trigger this down here, we can launch the flying machine, and it can travel any distance that we want until it collides with blocks that it can't move. Then all we need to do is trigger this observer, and it'll start flying back. Provided that I actually put the blocks in properly. Don't worry, I'm a professional slimestoner clearly. And the best part is that the whole thing is vertically tileable, allowing us to extend it all the way to the max height that a spruce tree can grow. So if I go ahead and just test it quickly, it goes all the way. Oh, yeah, I'm starting to think that maybe I'm not a professional slimestoner. Oh dear god. Well hey, at least I discovered a self-assembling staircase. Although not a very good one. Alright, now that we actually have blocks to stop the flying machines, we can launch them, have them stop, and then these observers in this circuit launches them again in the opposite direction, so they park right back where they started. The use of flying machines to crush leaves in tree farms is not very optimal because they're very slow and take a long time to process a tree. However, in this particular case, it doesn't really matter how fast we process the trees, because what we really want is the podzol, which is going to take time to process because we're limited by the single block stream. Now copying the leaf crushers to the other side, and we run into a little bit of a problem. We have these dispensers that we need to supply bone meal to, and the only way that I can really see us doing that is by punching a hole through here and running some dropper lines. If we try to clock these repeater lines, like so, most of the droppers get powered. However, at the very end, these repeaters stay constantly powered, meaning our actual dispensers are not dispensing. Interestingly, this problem can be fixed simply by using comparators all the way until the end and then have a repeater. This is because repeaters have a higher tile tick priority than comparators, meaning repeaters will want to power before comparators, allowing you to clock this line at the max speed without the repeaters at the end staying constantly powered. To trigger both sides of the leaf crushers simultaneously, we can use this simple rail-based instant wire that I was shown by Eagle, who I play with on the Wavetick server. All this is a block update detector, where if you send it a block update, it can synchronize events over very long distances. There is one problem that our leaf crushers won't be able to contend with, and that is leaves generating at this bottommost level where the podzol generates. The problem is that we can't run flying machines down here because the flying machines would get stuck to the podzol. To deal with this, we can have sticky pistons which push the stone upwards and then retract it again prior to the moss being generated. And with perfect timings, you can get all of this done in one swift operation. So here we would be replacing the podzol with stone, while also flushing all the items to the center. As you just saw, we extended the stone up, then retracted it, generated the moss, and then had water flowing for just long enough to remove all the crap above the moss. Here's a neat trick for fine-tuning any timings. Now, in my hotbars, I have something that I like to refer to as my timing blocks. These are command blocks that run a special command with Minecraft's scoreboard system to give me exact timings. In order to create the counter, I need to run this command, and then using a repeating command block to increment the counter, I can very precisely time the amount of game ticks between redstone activations of these command blocks. This means if I'm analyzing a specific circuit like this for example, I can place one of these command blocks at each one of the redstone inputs and get the exact difference in game ticks between them. If we take a look at the dirt farm, this circuit right here is a very specific delay for when we remove the water after the moss has been generated. Let's say that I had no idea what this delay should be. What I can do is apply another trick where, using carpet mod, you can use command tick freeze in a command block activated by the circuit that you want to analyze. And now, if I trigger the whole system and run through the whole operation, there we go, we're now frozen. I can now begin tick stepping. And now I know that water will try to flow every 5 game ticks. So if we count 1, 2, 3, 4, 5, the water should start flowing now. However, our timing is off and the water has been removed before it could actually start flowing in the first place. So already I know that this delay is way too short. Let's try increasing it with a few repeaters. And there, now the water has started flowing. If I step exactly 5 ticks, the water got removed before it could move another block. Let's try increasing this delay a bit. We're still removing the water slightly too early. Bump up the delay one more, and hopefully this should be enough. Here we are at the moment where the water starts flowing again. Let's go ahead and step by 5. And now, our water has flown over to the second block. We step again. At this moment, we remove the water block. However, the water is now continuing to flow. And hopefully, yes, so this should be actually the perfect timing. Because as you can see, the water has just managed to remove all of the stuff above the moss blocks. But also, the water subsides as quickly as it possibly can, meaning we can now grow a tree at this moment. So essentially, by fine-tuning these timings, we can ensure that the water is blocking all this moss for the shortest time possible, so we can start growing trees again as quickly as possible, giving us as least downtime as possible to maximize our rates. A little while later, with all of the timings fine-tuned, I went ahead and built up the rest of the circuitry. A funny quirk of this farm is that in order to get the player into a position where they can place down the saplings, I'm using a boat which is sort of levitating on an edge like so. So if I go ahead and align this boat, then automatically moving the player back and forth is as simple as extending this piston. Isn't that neat? In order to actually detect the tree growth, I'm using this simple push limit detector developed by Kaylee. The moment that it detects that a tree has grown in the chamber up here, meaning that all this moss should have been converted to podzol, it will trigger the instant wire that then activates all the systems which replaces the podzol with stone and then prepares it for the next cycle. Then all that was left to do was simply hook it up to the omnifarm. Now one slight issue is that if we just use the mixed box loader, what we get is not just dirt but also the logs and the cobblestone all mixed together in the same box. In order to remedy this issue, I've gone ahead and added this additional box loader which is dedicated to dirt blocks. So up here it has an item filter for dirt, and so the shulker boxes that we get out of this should only contain dirt. To get into the dirt farm section, we want to go all the way back to the elevator, like so. Then we're presented immediately with the bone meal input. And if we go around here, we can find the door to get inside of the growth chamber. To start the farm, I can take these spruce saplings out of this barrel and then jump into this boat. If I put my cursor just so that it's on these log blocks, I can then start placing down the saplings. And it's that simple to start the dirt farm. While the dirt farm's running, I've added this system up here to redirect all the items into the new box loader array where we can filter off the dirt, and then the other junk that we don't want, such as the cobblestone and the logs, they can just despawn in this loop. And then to turn the farm off, simply put the stack of saplings back in the barrel. Now, one thing to be cautious of once you stop running the farm is that if you accidentally bump this boat, you're going to have to grab yourself some blocks and just realign the boat by moving the boat back against them, like so. After tick warping the farm for an hour, these are the final rates that we get. And we only use 4 shulker boxes of bone meal to get roughly 8 shulker boxes of dirt. This insane bone meal efficiency can be attributed to the fact that we literally recycle every single organic that comes out of this farm back into composters to create more bone meal, which we recycle back into the input for the farm. So now that we have neatly filled shulker boxes of dirt, we can recycle these back into a system that converts them to mud and possibly into clay. However, this video is already 30 minutes long, and so that's going to have to wait for the next video. This was probably one of the most challenging technical builds I've done in a while. So I hope you guys enjoyed going through a detailed look of my design process. And of course, if you want to be notified about when future videos come out, be sure to subscribe, and I will see you next time.